systems, with the fifth principle being bringing grazing back to the our systems. But of these four principles that we have here, cover crops address three of them at least pretty head on. And so that's why in our soil health journey and our systems that we want to build to build a better soil, we always need to talk about cover crops being in that system and a part of it. Why cover crops? Why do we want to do them anyway? Why do we want to put them in our system? We know there's lots of benefits, but why do we do it even if we're not getting cost sharing? What are the benefits to be gained by the use of cover crops in a system where we're not getting cost sharing, and how can we justify that cost? And we know there's a lot of them, but what are they? Here's a list of some of the more common things we talk about when we talk about using cover crops and why. Of course, the first one is one of the erosion control is one of the main reasons that people started using cover crops back in the day. You know, it was to keep the soil covered through the winter when we get these hard rains. Nutrient scavenging. We know that generally there's a lot of leftover nutrients after our cash crops. And many of our cover crops, radishes and a lot of our grasses can scavenge those nutrients and tie them up and keep them from being lost through leaching and other ways, and make them available for the next crop. Building soil organic matter, it's what we want to do. We know we're farming a depleted resource, and so we want to build that soil organic matter back up for many reasons. But the three in the middle here that they're highlighted in red: weed control, moisture control, and temperature control, are the three that we want to talk about today, and how these benefits may not be some of the more common, but maybe some of the more important. We know if we use legumes in our cover crop mix that we can fix nitrogen from the atmosphere. We can improve the soil structure, reduce compaction, build a soil that's not so susceptible to the heavy equipment that we tend to put on it. Grazing, if you have cattle, we always want to talk about bringing livestock back to the system, but they do provide that benefit of some grazing outside of our normal pastures. And perhaps the most important that always want to talk about, we have to build a resilient soil. It's irregardless of where we have climate change or we just have natural fluctuating climates, but we have to be able to deal with changes and even out the highs and the lows, even out the wet and the dry years, and try to build a soil that can produce a crop every year and produce a good crop every year. So that's what we want to talk about. That's our soil health journey, building that resilient soil. It is all about the soil organic matter. We know that over time, if as we've looked at soil organic matter levels in our soil since the conversion from either woodland or from prairie soils here in Indiana, that we've lost a significant amount of our original soil organic matter. And one time we thought we possibly couldn't ever recoup that, but we're finding out with some of these systems that follow our four principles that we can build that soil organic matter back, and we can build a resilient soil, and we can build a soil that deals with changes, and we can build a soil that will produce a good crop every year. So our ultimate goal with our soil health journey, with our systems, with our cover crop, with our four principles, is to build that soil organic matter back to a level that's closer to what it was before it was converted to cropland. The mining of soil organic matter is not an option in our current systems, because these are some of the benefits of each percent of organic matter that's in your soil. The 10,000 pounds of carbon relates to the ability to be resilient and to develop a healthy soil. 1,000 pounds of nitrogen. Do we always need to put on commercial nitrogen? I think we're finding out that we don't have to. 100 pounds of phosphorus, 100 pounds of sulfur. But that bottom one, every 1% of soil organic matter levels you have means you have a soil that can store anywhere between 3/10 and an inch of water, and we can infiltrate it, we can store it, and that's the main overall arching reason that we talk about building a healthy soil through improving our soil organic matter. But maybe the most important thing is that water. What value can you put on an additional half an inch to an inch of rain in August during a dry summer? In 2012, most of the Corn Belt was under a pretty significant drought, And that half inch to an inch of rain, the potential to store that half inch to an inch of rain, could have been the difference between a crop in 2012 and other really dry years that was, not so bad. It was a pretty decent crop, and maybe a total crop failure. It's not necessarily how much rain you get, but when you get it, and it coming at the right time during pollination or ear fill or that kind of thing. So as we talk about our soil health journey and trying to build a resilient soil, it's to deal with these outlier years like 2012 was, and to store water for those dry years, so we can at least even out the highs and lows from year to year in our crop yields, and always to produce a crop that is at least average or better. So that's the soil health journey, trying to store that water. The meat and potatoes of cover crops. So, we talk about basics that we always want to talk about when we talk about a system, but the one thing we always encourage you to do is when you get ready to plant a cover crop, always have a purpose in mind. Always have a reason, or a primary and a secondary purpose that you want that cover crop to do for you, because your purpose dictates what species you'll plant, when you'll plant, how you'll terminate it. Are you going to terminate it early? Are you going to plant green, terminate it later? What species do you want to try to build a soil organic matter? Are you trying to keep the soil covered? All those kind of things dictate what you're going to do with your cover crops in your system. So always have a purpose in mind. It may change from year to year. It may change from field to field, but always have a purpose in mind when you take the piece of equipment you're going to plant cover crops out there and start planting. Okay, let's start talking about those three things that we talked about earlier that we were going to talk about today, and that is weed control, moisture control, and temperature control. And probably the key to those, all three of those, is the use of cereal rye as your cover crop. And cereal rye, of course, is a cereal grain. It's an overwintering spring growing species. So the lack of fall growth doesn't always mean that you'll not have issues in the spring with termination, or that you'll not have any cover at all, because what you have today or over winter does not necessarily mean what you're going to have in the spring. So you always got to be prepared to deal with it in the spring, have multiple plans in place. But cereal rye grows all winter. It can put roots down 40 inches deep, and that's why it takes off and grows so well in the spring as it starts to warm up. But one thing we're always cognizant of with cereal rye is the carbon nitrogen ratio rises as it matures. It's fairly low when it's in the vegetative state here, like in this picture, but as it moves towards maturity and senescence, then that carbon nitrogen ratio uh, comes up drastically. But that high carbon to nitrogen ratio is what we want if we want season long mat of carbon, or of rye cover crop on the soil surface. So we want that high carbon nitrogen ratio, but it does provide challenges that we have to be prepared to deal with. Okay, so this chart gives us some average carbon and nitrogen ratios of different cover crops and different species, and you'll see here is a rye cover crop is in the vegetative state. When it's growing early in the spring, it's somewhere around 26 to 1, and the soil microbiology like a 24 to 1, and so it's pretty close to that. But as it goes towards enthesis or maturity, it gets up towards 37 to 1, and then rye straw is 82 to 1 of the highest carbon nitrogen ratios of anything, of any crop that we might put out there. So while it will present challenges from a management standpoint, it is the reason that we can use cereal rye as a cover crop after it's terminated, to protect the soil through the growing season. So always be thinking about your carbon nitrogen ratio, because it drives our system, and we always have to be prepared to deal with the challenges it does present. Okay, a little bit about cereal rye spring management in our systems, and of course, in Indiana, we're pretty much corn and soybeans, but we can plant corn green into mature rye. I wouldn't necessarily recommend it if you're just getting started in your soil health journey and the use of cover crops, because it can provide challenges. Because corn needs nitrogen, we all know that, and if we have this mature rye laying on the soil surface, that that the microbiology in the soil will use up the available nitrogen to start breaking that rye down. And so, if you're going to try to plant corn into mature rye, you have to pretty much be ready to put some starter in your planter and give that corn some early nitrogen, and you better be potentially ready to early side dress because you might have some corn that's a little bit nitrogen starved, and so we don't want that. So be cognizant of that if you're planting corn into cereal rye green or a very mature cereal rye. Soybeans, on the other hand, they respond to nitrogen starved environment. They like it. They respond to that by potentially starting to nodulate quicker. Soybeans need nitrogen too. I mean, they probably need more nitrogen per bushel than corn does, but they have that ability as a legume to produce their own. So they will respond to that nitrogen starved environment if you have that rye mat and start producing nodules quicker and start that nitrogen cycling. So let's start talking about our three benefits of cereal rye mat on the soil surface that we've been talking about in this presentation. The first, we're going to talk about some moisture control, and we know that if we have that mat on the soil surface, that we're reducing evapotranspiration, we're protecting the soil surface from the hard beating sun. We know that we can prevent soil crusting. I mean, soil crusting is the relation is strictly tied back to tillage and the soil surface not being protected, and we get these rains and we get the first erosion when the soil particles on the surface break down and start to move in, and then we get a hot sun that causes that crusting, and we can deal with that and prevent that with this mat such as this picture has in it of cereal rye. We keep the soil surface moisture. If you go out into a field and you rake that rye back on a hot day, and you're going to see moisture there, where if you're out in a field that doesn't have any, you're going to see a lack of moisture in the soil surface. And we know that this allows for more infiltration. That's the whole idea. We don't want runoff. We want infiltration. We want that water in the soil where it can do work for us, and not running down our streams and taking nutrients and sediment with it. So we know that we get heavy rains during the summer. That's July typically is the month we get the most rain in the year. So if we can protect the soil when we get these heavy rains, that we'll put that water to work for us and store it for later uses. One of the major input costs that most farmers have in their system is weed control, and so can we use cover crops to offset some of these herbicide costs? And a lot of weed seeds need sun to germinate. If they're laying on the soil surface, this cover crop mat will keep the sun from the soil surface and keep some of these weed seeds from germinating. And a system of no-till and cover crops, if we can provide a better habitat. One thing that is starting to become more prevalent is the discussion of beneficial insects. And there's several species of beetles that live in the soil. These beetles feed on weed seeds and slugs and other things, and so, but they don't like their habitat destroyed. I mean, they don't like their home destroyed. And if we can keep a cover of cover crop residue out there, they live under that residue, and they spend the night eating weed seeds. And a cover crop mat's especially impactful in the source of some of our herbicide-resistant weeds. Water hemp is a serious problem in Indiana. Mare's tail has become resistant to some herbicide applications, and Palmer pigweed is unfortunately headed our way. So we need to be prepared to deal with these in other manner besides herbicides. And cover crops have an impact. It's shown that cereal rye can reduce the issues with some of these hard to kill weeds, and there's reasons with the sun, keeping the sun off the surface is one, and another is if we can keep these weed seeds from germinating for a period of a few months, then they lose their ability to germinate. So the whole idea is to keep them from allowing to germinate, keep the sun off the soil surface so they won't germinate for us. And so if these cover crops can help us suppress weeds, then potentially we have another tool in the toolbox to deal with the control outside of herbicide use. And hopefully, if we can reduce herbicide use, we can reduce the potential impacts of herbicide use. And so, if we use cover crops to help us with weed control, we get all these other benefits that we talk about that come with them, and to build a healthy soil. So weed control, if we have that mat out there all during the growing season, we can get some real benefit from our cover crop. Soil temperature control is another one of the many benefits of having a growing season-long mat of cereal rye residue. Every form of commercial nitrogen that we might use has to pass through the form of microbiology to, to convert it to a form that plant roots can pick up and use. And most microbiology are just like Goldilocks. They don't like it too hot or too cold. They like it just right. And so we want that mat on the soil surface to protect the surface and to get us a constant temperature so we don't have these great fluctuations between night and day. And when the microbiology are happier, they're just like we are. They're more active, they work harder, and they do more for you in producing available nitrogen. They usually like it somewhere in the 80 to 90-degree range. That's when they're most active, but and they can actually, we can sterilize the soil if the soil temperature gets over 120 degrees or 115 degrees. So when the soil temperature becomes too hot, the microbiology can die, they can go dormant, they can go deeper in the soil. They reduce this nitrogen availability and efficiency that we need right when our corn crop needs it. Well, this might be seem a little cartoonish or for the average farmer, but there is a lot of good information here. And as we want to talk about the differences between having the soil covered and protected from the sun and from the other elements, and having the biology fed, and versus a bare soil. And we know that there are major benefits over time to having keeping the soil covered through as much of the year as we can. So we can learn through something that's for maybe for kids, but as adults we can learn from it too, and learn that as we go on a soil health journey, there are things we can do to build a better soil. Okay, let's talk about some considerations in the use of cereal rye for these three purposes that we've talked about. And in general, you're probably going to have to bring your seeding rates up if you want season-long soil surface protection. If you're just using a cover crop for other reasons, that may not be enough. And so you're probably looking at bringing your seeding rates up higher than you would normally. And as you stay in this system and as you build soil health and as you get your microbiology working for you, over time, you're probably going to have to bring them up even more, because the soil biology, you get it to doing its thing and build the soil health, and all of a sudden you have trouble keeping surface covered with residue because the biology is breaking it down faster and faster. So, that's something you'll need to talk about, think about, be prepared to deal with as you move through your journey. And another thing we want to talk about when we're doing this is potentially putting the rye on the ground with a roller crimper. Whether you terminate it with a roller crimper or you terminate with herbicide and then put it on the ground, getting it down on the ground and getting it flat on the surface provides that season-long control that we'd like to have. And so I can't reiterate enough that you need to have a nitrogen management plan if you're planting corn and doing this. It is going to tie up nitrogen. You're going to have to deal with that in whatever way, whether that's side dress, whether that's putting it on with a planter or some other manner. You're going to have to front load some nitrogen when you're planting corn into these high carbon and nitrogen ratio cereal rye mats. This is just a list of some resources to help you out. There's a lot of good information out there. You can usually start with your Soil and Water Conservation District and Natural Resources Conservation Service office. The SARE book is an incredibly good resource. You can pick those up either as a digital or you can purchase a copy, but it has information on about everything we ever planned as a cover crop. The Midwest Cover Crop Council has a tool that helps you decide what species to plant. Our NRCS seeding tool helps you with rates and developing mixes and so that we know that we're getting enough seed out there. And it's just some information. And one thing I didn't put on here, that always look to find someone in your area that's making it work on your kind of soils, your kind of climate. But find a farmer, find a mentor, find somebody that's willing to talk to you about how they made it work, and to help you from making some mistakes. And, we don't want anybody to fail. We want everybody to succeed and to continue on this journey. So always look for a mentor to help you out. Well, it's time for some questions or comments, and I hope that this presentation has helped you. I hope it's helped you start thinking. That's what we want to do, to plant seeds, to continue on your soil health journey, to not look back, but to look forward. We want everybody to move forward, and there are, over time, this is not a quick thing. It takes time to develop these systems. It takes time to build your soil, and over time, we know that there's economic benefits to be had from the use of cover crops that goes way past the cost of cover crops through improved soil health and improved ability to deal with changes in our climate, in our rainfall, and all those kind of things, and over time potentially reduce some commercial inputs. If we could reduce them, that's an economic benefit as well as a potential environmental benefit. And so we want to be not only regenerative from a standpoint of our soil, but regenerative and sustainable economically, because if we can't do that, there's no sense talking about anything else. It has to be sustainable economically. So if you got any questions, feel free to get with me.
All right. Well, Don is here, so you can get with him. Don, you have anything you want to add?
No, I don't think so. I mean, I just encourage that, that we are here to help people as a soil health team in the state of Indiana. We're here to help people through the journey, and there's a lot of good farmers out there that have done some really, really great things. And always encourage any new person moving into a system to find somebody to help them along, because they've made a lot of mistakes. These guys that have made it work, and we can eliminate some of that up front. So if anybody's got any questions, I'm free to or willing to answer them if I can.
Questions for Don? Anything in the chat? Maybe we got something in the chat. Let's see here. Okay, I have one, John. Are you pretty happy with the cereal rye?
I think so. I mean, the rye that we've used here in our area, we've gotten really good results. The one thing I probably didn't mention that I probably should have is if we get into some of these developed high management systems, we may need to look past planting variety not stated rye and start moving into some of the variety ryes that all go to maturity at the same time, especially if we want to roller crimp them. We really need that rye to mature, every grain of that rye or every plant of that rye to mature at the same time, so we can take it down with a roller crimper.
Gotcha.
In an organic system, in a system, we're trying to reduce herbicide use, but that is one thing we need to add is we need to look to that, and we need to look to development of some varieties of rye and other cover crops as far as that goes.
Gotcha.
Hey, Don, how about a simple cover crop mix of a grass, a legume, and a brassica?
Well, it depends a little bit on whether you want it to be a winter kill. I mean, a simple, easy mix to start with before corn is oats, radish, and crimson clover. If you get it planted, my birthday is October the 7th. I always say it has to be planted by my birthday. That's an issue, of course, in a lot of our systems, especially up north there, where you're going to have later harvest. So that is a winter kill, except for the crimson, and for the most time, probably up there, the only thing that would survive winter is crimson, and it may even have a little bit of trouble. But and crimson's really easy to take down ahead of corn. But if you want something to survive all winter, then you're probably looking at rye or triticale. Triticale, of course, a cross between wheat and rye. It has some grazing benefits, but probably not the hardiness of rye. And, if you're going to graze it, you may want to work some triticale in. But we're moving a lot of other things. I think rape is a viable alternative for radish in a lot of ways. Rape seed is dirt cheap. It's easy to control. If you want to put rape seed in a lot of your mixes. We're doing some other things. If you want to terminate a legume, you're looking at, with a roller crimper, you're probably looking at Balansia clover. Balansia is one of the clovers that it has a hollow stem, and it can be terminated with a roller crimper versus crimson, which cannot, or red clover, which cannot. Hairy vetch can be terminated with a roller crimper too. It's just, that's another set of management decisions with hairy vetch. You've got to be able to have the planter set up to be able to plant through those. There's a lot of peas you can plant. You're talking about a lot of things. It's kind of where you at in your system. We got guys that are planting peas early in the spring, and I saw a video the other day of a guy had planted peas, and the peas are vining up the corn, and he was shelling the corn with all the peas vining up it. So he had a perpetual cowpea crop through the summer. He was getting some nitrogen out of and some soil health out of growing up in the corn. And he actually tried the Three Sisters thing. He'd planted peas, some squash in his corn, doing the Three Sisters thing, trying that. So it just depends on where you start. I start with something you're comfortable with and move forward in management. Don't start with any of this hard stuff up front.
All right, Don, thanks. Let's move on to our next video. That's provided to us by Shalimar Armstrong. Shalimar is a professor in the agronomy department who's been looking at the very mechanisms of how cover crops work, how they manage nitrogen, and how they behave in our systems around the state. Shalimar's here today, so he'll be able to answer some questions afterwards. So let me get this video started and attempt not to kill it again.
All right, thank you, Sean, for that intro, and it's a pleasure to be a part of this group, this classic, and I hope that I can do well enough to be invited back. So I want to start off with just an intro. Over the last 10 years or so, or the last decade, there's been a dramatic increase in cover crop adoption, I think mainly due to two factors. Number one, we want to farmers are looking to be more efficient with their nitrogen and nutrient use. And so they're adding cover crops to increase their nutrient, to reduce the loss of nitrogen through tile drainage and also through overland erosion. Also, farmers are looking to be more sustainable, right? And so in order to increase their soil health, and their productivity long-term, they're adding cover crops. But even with cover crops being known to do well in these two categories of nutrient loss reduction and soil health, there's only less than 5% row crop acres that actually receive cover crops nationally and within the upper Mississippi River Basin, right? And so that means when you look at that farmers are having questions, okay? Still having many questions before there's wide scale adoption. I think one of the major barriers based on the literature is nitrogen cycling, nitrogen being one of the larger input for corn production, row crop agriculture. And so I put together this model that's made from, developed from 3 or 4 years of data, where I'm just showing the dynamics of available soil nitrogen over time during the life cycle of cereal rye, which is one of the most commonly adopted cover crops in our region. Okay, so on the vertical axis you have nitrogen, all right, pounds per acre. On the horizontal axis you have different scenarios. So the first is a no cover crop scenario, right? In this scenario, in the spring, you have about 72% of available nitrogen in the soil, okay? But at the same time, you're losing about 28% of that through the tile water, through tile drainage, subsurface drainage. When you add cereal rye to the system, you significantly reduce what's available, okay? And so it goes into the plant. Cereal rye scavenges that nitrogen, so about 51% is scavenged from the soil. And in doing that, you reduce what's lost in the tile drainage, okay? And so in theory, you expect what's in the cereal rye to decompose and over time mineralize and contribute to that brown. The green would contribute to the brown over time, and your subsequent cash crop, let's say corn, would be able to utilize some of that nitrogen after the residue decomposes. But what we're finding in our experiments and investigation is that the reality is that you can almost count that cereal rye scavenged nitrogen as non-available, bioavailable, for plants. Okay. However, you're still getting that reduction, but that nitrogen that's in that cereal residue, the utility of it is very low. And so we decided to dig into that. So that really brings an adaptive management, we like to call challenge. So on average, about 40 to 60 pounds of nitrogen is in the biomass of a good cover crop stand in Indiana, Illinois, where I do my work. And so we have to find out, how do we supplement the system for what the cereal has taken, okay? So to further study this, we did an N15 incubation study, which simply means that we can label nitrogen, feed it to the cereal, take its residue, and study the release of nitrogen over time. We did an incubation. We were able to calculate growing degree days, and on average looked at growing degree days and how they correlate with growth and development stages of the corn. And we looked at how nitrogen, the fate of that nitrogen from the residue, and how it moved into four different pools of nitrogen in the soil. So first pool being the organic pool, the microbial pool, the undecomposed cereal nitrogen pool. So that's the pool that says that this residue, I can still see it with the naked eye. So we called it undecomposed, but it still contains a percentage of nitrogen. And then finally, the inorganic N pool, which is represented by the green cover. And what you'll see that over time, undecomposed is reduced from 85% to about 27%, right? And then over time, you have your inorganic N pool growing and expanding upwards to, at R6, 14%. So only 14% of the nitrogen that was in the cereal residue was actually in a bioavailable or a plant available pool at R6, right? So by that time, the plant is done, it doesn't really need it. And so what this is demonstrating is that at R6, the largest pool where nitrogen resides that was derived from the cereal residue was the organic N pool, right? Meaning that it's not available, it's not available to your subsequent crop. Another 27%, the second largest pool, was undecomposed, meaning that again, it's not available. Only 14% was available. So hang on to that number, 14%, as we move from the bench, from a bench study to the field, looking now at the recovery of cereal residue nitrogen, again, using 15N technology in both corn and soybean over time and different growth stages. And let's just, for the sake of time, jump right to harvest. So at harvest, when we sampled only above ground corn and soybean, we were only able to recover 10 to 7.3% of the cereal N respectively for corn and soybean. So what is this saying? I'm just going to summarize these results. You cannot depend on cereal nitrogen to be available for your subsequent cash crop. Only about 7 to 10% will be available. So then the question becomes, how does this interaction between cereal and soil nitrogen affects the cash crop yield? Okay, how does that impact yield? So when you think about soybean yield, it's not really a big impact. And I'm showing only 2016, but this is basically representative of all of my studies with cover crop cereal and soybeans. There's really no significant difference. Now, corn, however, is trickier, right? In some years, like 2015 on your left, you have good early spring warm-up, good soil mineralization. So there's a lot of nitrogen available that's soil derived, therefore making up the difference for what the cereal had scavenged during the fallow period. And you're not really getting a significant ding when it comes to yield, only in the spring treatment in 15. However, in 2017, we had a slow warm up and we also had record rainfall. And so the combination of those two with the residue caused for there to be a significant reduction in yield for both spring applied nitrogen and fall applied nitrogen. And again, this is the worst case scenario because we did not apply any starter at this point. So we dug into this reduction in nitrogen in yield, and we found that there was a reduction in nitrogen uptake that was supporting that, that corroborated those findings. So after tons of plant sampling, we measured in uptake for above ground corn plant samples across different growth stages from V6 to R6. And we looked at the in uptake, and what we found was at about V12, we see this development of a nitrogen gap, which at R6 ends up equates to about a differential of 60 pounds per acre, right? That is not there in plants, in corn plants that were grown in cereal rye residue. We also dug into the microbiome and found that this at about 60 to 75 days after termination, this is the time when the microbial community is really at its highest activity. And so we think that this could be due to two things. Number one, nitrogen immobilization due to the carbon being added to the soil solution from the cover crop decomposition. Number two is just there's a point here where the nitrogen demand by the corn is exceeding the ability of the soil to supply it in cereal rye plots. So it's an opportunity for us to think about how can we manage cover crops and how can we manage nitrogen in cover crop fields in order to close that gap. So number one, you either going to supplement what the cereal rye took away and scavenged, or you're going to, and you could do that through actual commercial fertilizer, late application of nitrogen. We're going to look at that first. Or you could, if you look to the far right, you could increase your inclusion of overwintering legumes such as Balanza clover, crimson clover, and so forth, to see through biological fixation can we get a nitrogen credit from the biomass of legumes as cover crops. Third, we can look at some precision planted cover crops. In other words, we manage a little bit tighter the way we apply or plant the cover crops so that we have zones where possibly nitrogen immobilization won't occur, right? So let's look at this first study. This is in Central Illinois. It's a Mahler soil and a little warmer than Wisconsin, right? But you're thinking about on average 3.5% organic matter, okay? So the objective here is to see if late season application of fertilizer can compensate for the nitrogen taken by the cereal rye to get competitive yield, equal or greater yield. The treatments, we had a zero control that received no cover crops, no fertilizer. Okay, then we had a regional control, which simulated what farmers were doing in the region. So in Central Illinois, they're still applying fall applied anhydrous. So a portion, 120 pounds, went down in the fall. At planting in furrow, 5 pounds, and then 100 pounds went down between the growth stages of V4 to V6, right, giving a total of 225 pounds of nitrogen applied commercial fertilizer. Okay, the regional control plus cover crops is that cover crop is cereal rye, and we basically just added cover crop to the same nitrogen management. And then we come now to adaptive 1 late in, and so we have the fall applied at 120, and the only difference here compared to the regional control is that we wanted to see if the 3.5% organic matter soil could support the plant in demand until we make an application with Y drops at V8 to V10. Okay, but we didn't increase the total in rate. It still was 225. Adaptive 2 is that we're going to make that V6 application with about 85 pounds and then additional 75 pounds with the Y drop at V10, giving us a total of 285. So 60 pounds more nitrogen added. And that 60 pounds comes from what we extracted from the literature and from the data, where you look at the in uptake difference between corn that was growing with and without cereal rye. And also that 60 pounds is really close to the average of about 45, 50 pounds of nitrogen that we have found over 6 years in the above ground cover crop cereal rye biomass. Okay. So this is just a shot showing you that we came in with Y drops and then the late season V10 application. And then we had a aerial canopy image and showing where you see those black circles. That's where we had the extra 60 pounds of nitrogen there. Those red blocks represent the zero controls. So let's look at the results. If you look at the bottom of the table, we'll start with corn N uptake at R6, so relative maturity. You see that the zero control, we had a total of about an average of about 54 pounds per acre. Regional control without cover crops averaged 264. And then there was about a 16 pounds per acre reduction when we added cereal rye to that regional control. It got worse. So the soil did not support not having V6 side dress and moving it to the later in the growing season to V10. So that resulted relative to the non-cover crop control to a reduction in about 86 pounds per acre of nitrogen. Didn't get into the corn plant. But then when we did have the V6 and added another 75 pounds at V10, we did get 293 pounds per acre in uptake, which equated to about 29 pounds per acre greater in uptake relative to the non-cover crop control. And when you look at it, the yield from this study was very similar to and mirrored the in uptake, right? Where you had the greatest in uptake, you had the greatest yield for the adaptive 2 at 227 bushels per acre relative to 223 for the original control. And so it's showing here that when we added cereal rye without supplementing for what the cereal rye had scavenged, you get lower yields, right? But when you add back that 60 pounds or so that the cereal rye scavenged, you get greater yield. And I'm going to talk about this on a presentation on Thursday, that although we added 60 pounds more nitrogen, we still reduce nitrogen loss via tile drainage by significantly relative to the regional control for the adaptive 2 late treatment. So moving on, we see now we're going to move to our precision planted cover crops experiment, and I'm showing you some preliminary yield data, but the biomass data has been published. This is a collaboration between Amir Singapore and my group from Southern Illinois and Purdue. And so basically, precision planted cover crops, the idea is that we come in after the harvest of the cash crop with a no-till drill, and we're able to stop up certain outlets for seeds where we can drill cover crops, cereal rye, let's say with 8-inch spacing in strips across the field, while leaving what we call is a skip row for the cash crop to be planted in the spring. So what you're getting is a non-intersecting growing zones of cover and cash crops, right? Which will give some flexibility in the spring, right? So if you don't have enough, you can plant and let it grow. If you have too much, you can terminate and still have a non-residue zone in order to plant your cash crops. And we were able to hit that with RTK guidance. We're thinking that this could reduce nitrogen immobilization, right? Because you don't have roots and the above ground biomass in that cash crop skip row zone. It can also increase the soil tilt in the spring when it comes to germination, things that are important to seed germination. And that is, the soil being able to dry, okay? And also warm up in that zone where you don't have the cereal rye planted, giving you more even and giving you good germination. Last but not least, we have the potential to reduce the overall seeding rate because we're not covering the same area. We're covering only 50% of the area. And so it's possible that with this management, we can reduce the amount of seed we need, but yet possibly get the same ecosystem services, the same biomass, same carbon generation in the biomass. And so I want to show some preliminary data. This is from the publication. And so when you look at NP, which is the control, where we did a solid drill stand of cereal rye versus STRC, which is the stripped cereal rye across the field, where we use precision planting techniques. And there was no significant difference in the biomass carbon that was accumulated per hectare. So basically you're getting the same carbon generation, right? That's going to feed your organic matter of your soil. And then on the right, you see a figure that shows basically 2 different years and 2 different sites. Despite year or site, we still got the same N uptake, which is critical because that leads us to think that we can get the same nutrient loss reduction from that cereal rye stand with 25% less seed. So we're getting the same biomass, we're getting the same biomass carbon and the same N uptake with 25% less seed. That possibly could pay off economically. Now, in the same study in 2020, we took yield, right? And what we saw simply is number one, when relative to the no cover crop control, precision planted cereal rye had equal or greater yield despite nitrogen rate 200 or 250 pounds of nitrogen. Number two, we're seeing when you compare the cereal rye treatments drilled versus precision planted out yielded the drilled despite N rate. So again, potential benefits, 25% less seed, equal or greater corn yield relative to the non-cover crop control, and greater corn yield relative to the drilled solid stand cereal rye treatment. So moving on to our third experiment, and this is, in this experiment, we're looking to increase the inclusion rate of overwintering legumes. So we looked at crimson clover on your right, and on your left, we looked at Balanza clover, right, to see if we can generate a nitrogen credit. We did this in southern Indiana, okay? So quite a bit warmer than Wisconsin. So here's just some results showing you a picture of the biomass. Basically, when you look across all 3 variables, you see that the Balanza clover outperformed, okay? So when it comes to biomass, Balanza clover had a range of about 2,500 to right over, a little over 3,000 pounds per acre of biomass, okay? Which equated to about 230 or so to almost 300 pounds of nitrogen per acre within that biomass, relative to only about a range of 45 to maybe 130 pounds per acre in the other treatments. Not only that, but the Balanza clover also, compared to crimson clover and other treatments, had a significantly lower CDN ratio. So the residue quality was greater where we had more biomass and more nitrogen. Normally that's a combination that results into nitrogen credits. So let's move on. So what we have here is the corn yield dry on the y-axis, and then nitrogen rates for the side dress, okay? So we did have 40 pounds of starter there at planting. And so these rates are representing the side dress nitrogen. And where we had 0 side dress added, we did have a significant increase. We have an increase of about 50 bushels relative to, on average, relative to the other treatments for the Balanza clover. And that's a part of that, that nitrogen credit coming from the low CNN ratio of the biomass and high utility for the subsequent corn crop. So with 0, only 40 pounds, we generated over 150 bushels per acre. Then when you move to the next rate of side dress, okay, which is about 65 pounds, so plus the 40 at starter, that equals to 105 pounds total. You're still getting 20 more bushels per acre for cereal rye compared to the control. and about 47 more bushels to the acre for the Balanza clover compared to the Harry Vetch. And so Balanza clover is still, you can see the nitrogen credit still showing up, and then it then diminishes over time as diminishes as you add nitrogen to the field. So one of the things we're trying to tease out is whether this the bushels produced by the Balanza clover at about 105 pounds, is it significantly different from the higher two rates, 120 and then close to 180? And if so, then this will be the optimum nitrogen rate for the Balanza clover, then corroborating the fact that it's generating a nitrogen credit. Okay. So to close and then to address some questions, I'm just going to summarize some of the key points, since two of these three studies are preliminary. So only 10 to 14% of the cereal rye residue N will be used by the subsequent cash crop. So you cannot ignore the nitrogen that's scavenged by cereal rye in your nitrogen management. In other words, we found success in putting that nitrogen back. We also found success as far as tile drainage, nitrogen loss, where we didn't see greater losses when we added that nitrogen, but did see greater yield. So that's some potential of maybe cereal rye before corn being competitive and more palatable to farmers for adoption. Secondly, precision planted cover crops, we can plant at a lower seed rate, but yet have the same benefits of equal biomass carbon, which could be viable and good for farmers for this emerging carbon credit market that's developing. Secondly, you're getting potentially the same nitrogen uptake and potentially the same nitrogen loss reduction, which is good with less seed. So economically, that could be palatable also. The inclusion of overwintering cover crops such as Balanza clover, and Balanza clover outperformed crimson clover. They were planted on the same date. We sampled on the exact same date. It was just the Balanza clover woke up in the spring and took off. It was not difficult to terminate, and it was not difficult to plant into, but it had a greater potential to generate a significant in credit compared to other treatments. So at this time, I'll take any questions.
Shalimar is here with us today. So you have any questions for Shalimar? Shalimar, I have one. What's the difference in the cost with the Balanza clover? Is it more expensive?
Ron, can you hear me?
Yeah. Yep.
Okay. I could, for some reason, when we transitioned, I lost audio. So yeah, at this time, I can address any questions that one may have via the chat, or just unmute and unleash.
Is the cost of the I had just a question, Shalimar. Is the cost of the Balanza clover higher or lower than the crimson clover?
Oh, that's a good question. I think that their cost is very similar, but
Okay,
both
good.
are higher than the cereal rye, for sure.
Okay, gotcha. That was a pretty interesting set of in response graphs at the end there. I mean, you're edging up on lower in application rates based on the inputs from the Balanza at a pretty significant level. Right,
and one key point that I failed to mention in the video is that we were able to plant this. This was a field that was flooded, and so we were able to come in a bit earlier. So that's a scenario. Pretend that scenario was planting cover crops after wheat. It's similar to that type of growing degree day accumulation that gave us very good growth in the legumes, in which is difficult to get as you move north. But the key is that we can combine some of these technologies, such as precision planting these cover crops, and so therefore imagine having you precision plant your Balanza clover, right? That starts slow and wakes up slow. So you have to be patient in the spring. So if you have these skip rows where your cash crop can be planted without the impact of the residue, like you would if it was solid drilled, you can be more patient in the spring and then take advantage of more spring growth from your legume that overwinters, right? So the literature says you need about 1,000 pounds of legume above ground biomass in order to see some signal of nitrogen credit with the subsequent corn planted. So you want to try to be patient in the spring when you didn't get a fast start, and it could possibly pay off very well. The neat thing about the Balanza clover relative to others is that it's easy to terminate, and secondly, although it had the highest biomass, it had the lowest seed-in ratio. So the quality of the biomass was greater. And we definitely saw that when you compared the crimson clover versus the Balanza clover.
Nice, nice.
It's a decent thought, especially for those that are thinking of organic corn production.
Gotcha. Oh yeah, good point. Good point. All right. We have one more quick video from Linda Propicki. Linda's here with us today, so she'll be able to answer some questions afterwards. Let me see if I can get this started without too much commotion.
Hey, Ron, while you're starting that, Gene Whitty has a question.
Oh. Sorry, go ahead.
Gene's question is, do you have research to show pre-plant or side dress on corn with rye cover crop? And Gene, feel free to unmute and ask yourself.
So yes, I do have 2 years that I'm summarizing. It was funded by the Indiana Corn Marketing Council, and we had multiple rates of starter from 0 to I think 75 pounds per acre. And it's interesting that our results varied with the type of year we had, right? So in the first year, we saw that 50 pounds of N at starter was the optimum. So if you go above that, you're not getting any more in uptake or yield. And we saw that at 50 pounds, 2 out of 3 sites, 2 out of 3 sites in the state of Indiana, we had equal or greater yield relative to the non-cover crop control that had starter. And also we had 3 out of 3 sites starter, cover crop, cereal rye, corn in cereal rye with starter out yielded corn in cereal rye without starter. But then this last year, we saw that side dress starter, the lowest starter rate yielded the highest because the corn demand was such that side dress was more important to that corn than starter. And so we saw the opposite. So in the first year, 50 pounds was the optimum. In the second year, 25 pounds was the optimum, right? And so it depends on the weather and how fast the soil warms up, how much rainfall you get, and the flush that you get of nitrogen that would normally be available to the crop from the soil and from side dress. So it varies. So I'm planning to produce a publication and some extension publications based on that information. So stay tuned.
All right. Let's get this last video going here. Maybe.
Hi, my name is Linda Propicki. I'm a professor and department head here at Purdue University in the Department of Horticulture and Landscape Architecture. I'm also the social science lead for the St. Mary's Watershed Project, and over the last several years we've been doing surveys and interviews with a number of both the producers and the conservation professionals in the watershed to better understand what explains the adoption of several different types of conservation practices. In this particular study, we've been looking at the continued use or the persistence of cover crops after cost share funding expires. We've been looking at 3 particular research questions in this study. When conservation program dollars end, do producers continue using cover crops? And many of the producers we've talked to have had EQIP funding, so we're particularly focused on when EQIP funding ends, what factors contribute to continued cover crop use, and what differentiates producers who continue using cover crops from those who discontinue. To answer these questions, like I said, we've been doing a number of interviews around the state. We've been doing our work in 4 different watersheds, here in the St. Mary's, in the Big Pine watershed, which is just north of West Lafayette, in the Lower Wabash, and in the Upper White. Our interviewees range in age from 63 to 79. They have all been male. Many of them have used multiple conservation practices, and they have varied levels of education and a pretty wide range of farm size from 350 to 2,400 acres. The key characteristic, though, of all of our interviewees, or most of our interviewees, is that most of them have continued using cover crops after cost share funding went away. Some of the factors we have found that have influenced this continued use is having a stewardship ethic, so producers who have a strong care for the land as part of their motivation have been more likely to continue using cover crops. Producers with a learning mentality, so people who like to try out new things and tinker and innovate, have been more likely to use cover crops. And of course, producers who see greater benefits from the use of cover crops than the challenges inherent in using cover crops. So when benefits outweigh challenges in somebody's mind, they're more likely to continue using the practice. We have found that while many folks have continued using cover crops after their EQIP funding has gone away, many of them have changed their seeding rate, the number of acres, and the type of cover crop that they've been using. So again, while they're continuing to use cover crop, they're not necessarily using it at the same level they were using before, so it might not have the same benefits that the government intended when they initially funded the cover crops. We found that financial resources and program length may limit persistence for some, and some recommendations that are starting to emerge from this work are that longer program contracts or the option to re-enroll might help with persistence, and greater flexibility in program contracts may also be helpful. We're continuing this work, so we're hoping to interview more farmers in each watershed to see if there are regional differences. For example, is there something inherently different about the farmers here in the St. Mary's, which drains into Lake Erie, versus farmers in our other watersheds, which all drain into the Gulf of Mexico. We also really want to interview more farmers who've discontinued use to understand what they have in common and what it is about cover crops that isn't working for them. If you yourself are a farmer who would like to be interviewed, if you've recently had cost share funding run out, and especially if you discontinued using cover crops when your cost share money ran out, we would love to hear from you. We'd love to interview you, or if you have any friends or colleagues who've discontinued use after their funding ran out, please feel free to send us their contact information. I'd be very happy to talk to them and find out more about why they discontinued use, so we continue this research to help inform how to better get more conservation on the ground. Thank you so much for your time today.
Thank you, Linda. Linda's here if you have questions. If you want to volunteer for the interviews also, she'd be happy to talk to you. She's looking for participants.
Yes, that was a shameless plug, that video.
It was totally a shameless plug. I loved it. It was great. It was not, you weren't even hiding it. It's great. Sarah Peel, you had an announcement you wanted to make?
Sandy does, actually.
Oh, Sandy. Where's Sandy? Sandy.
Hi there. Yeah, I just wanted to invite you all. We are beginning a 3-part webinar on planting green. In fact, Jean Whitty, that asked a question a little bit ago, is one of our presenters on February 17th. Is going to be our first one at 10 o'clock in the morning. That's no-till corn into cover crops. And Jean and Ron Musser, who is the district conservationist with NRCS, will be speaking. And then on March 17th at 10 o'clock, we have herbicides for interseeding and cover crop roller uses. And Dan Kaminsky is going to be sharing information about that. And that's also at 10 o'clock. And then April 7th, we changed that to the evening because we thought some of our guys might be in the fields then. And that is interseeding and fall season cover crop selection. And Dean Tonner, who is on our board here at the Soil and Water Conservation District, will be speaking. And he's 100% cover crop farmer in our area, and also Dan Kaminsky. And each one of these sessions are only an hour long. And so I just wanted to invite you all. The registration is really easy. You go to our website, which is www.adamscountysoilandwater.com. www.ccc.com/register. So
It's pretty
thank
easy.
you. Yeah.
Excellent. All right. Well, I want to thank everybody for coming out today. We continue the series next month. Alyssa, what date are we on next month? Can I ever remember? Just drop it on Alyssa so she can try to figure it out.
Thursday.
Yeah, I don't know. Sarah,
Thank
do
you,
you have
Linda.
it?
That would be March 4th, the first Thursday of the month.
And we're going to talk about dollars and
Uh,
cents next month.
Dollars and cents, yes.
So how to get into some of these programs. So that'd be great. So I look forward to seeing you all then. Thanks.
Thank you.